Let's try this approach, medyo hopefully mas visual. Consider this function, f of x equals 3x cubed plus 4x squared, etc. So, pareho sila ng degree 3, numerator and denominator. The leading coefficient of the numerator is 3, the leading coefficient of the denominator is 4. So, maybe before we continue, you can make a guess kung ano yung magiging horizontal asymptote natin. Now, ito natin siya i-visualize. As x approaches negative infinity, so yung x natin, let's say itong red line na to, negative siya. So, red for negative. Meron tayong 3x cubed. So, cube. May cube tayo. Then 4x squared. Ginawa kong green kasi kahit negative yan, magpa-positive siya. 7x plus 2. Ngayon, ang titignan natin dito, ang gusto ko ma-visualize ay, since malaki-malaki na yung magnitude ng x, this will be a very, very large value in terms of magnitude compared dito. Like, sabihin natin, 100. 100 cube is so much, much more larger than 100 squared, which in turn is much larger than 100, di ba? Which is also much larger than 2. So, ang laki ng difference ng size ng first term sa second term, sa third term, sa fourth term dito. Kasi the first term is being cubed. Kinu-cube natin ang isang malaking value. So, if we expand yung fraction na yon, na syempre same denominator, dahil sobrang laki nitong value nitong cube na to, itong buong fraction na to, napakaliit na ng value niya, na it will approach 0 habang papalaki ng papalaki yung magnitude ng x natin. Sobrang mag-zoom up yung value ng denominator, making insignificant kung ano man yung laman ng numerator. Same here, dun sa x squared. Kahit x squared siya at malaki siya, cube to eh. So, habang palaki ng palaki, yung value ng x natin mapuntang negative, sobrang bubulusok yung laki ng denominator at sobrang bubulusok din yung value ng buong fraction pababa, pa zero. Sobrang liliit siya. Na ang magiging significant na lang na term ay yung first term na lang, yung magiging halos significant na value. Pero pinapalaki pa natin ng pinapalaki yung x at papalaki ng papalaki yung value ng x cube. So, itong terms dito sa denominator, yung second, third, and fourth terms, nagiging insignificant na rin sila. So, we can approximate the value of the denominator na ang masusunod na lang yung 4x cubed. So now, what will this expression approximate? This is approximately 3x cubed. Siyempre, approximate kasi meron tayong mga inassume na malapit ng mag-0 at tinanggal. Yung denominator din, approximate lang. Kasi sinabi natin na sobrang liit na ito to be significant. So, hindi siya malinis hindi siya magiging malinis na cancellation. But it's close enough that we could just approximate the value of the whole thing for very, very large magnitudes of x to be just equal to 3/4, which are the leading coefficients of both the numerator and the denominator. It's the same argument kung mag-approach tayo ng positive infinity. So that is the reason kung bakit ang horizontal asymptote, pag equal yung degrees ng numerator at denominator, it's just y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Yan. So summarize, if the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is given by the equation of the horizontal line, y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Recall, nung simula, ang una nating example, yung degree ng numerator, mas maliit sa degree ng denominator. Horizontal line din yun. So, what if ganun yung case? Kung ganun yung case, balik tayo dito sa diagram na to. Isipin lang natin na wala yung leading coefficient. So parang 0 times x cubed over 4x cubed. So 0 over 4, edi our function will approximate 0 pag malayong-malayo na. Kasi sobrang lalaki yung denominator compared sa numerator. Which is why, if the degree of the numerator is less than that of the denominator, our horizontal asymptote, which is kung ano yung approximation ng function natin for very large magnitudes of x, it's just y equals 0. Let's take a look at this function na mas malaki na yung degree ng numerator sa denominator by exactly 1. 1 lang. So, degree 3 over degree 2. This is the graph. Horizontal asymptote is y equals x minus 2. Paano natin makukuha yon? Well, first we rewrite the fraction by doing long division. So this is the numerator, this is the denominator. We are dividing x cubed minus 3x squared minus 6x plus 8 over x squared minus x minus 2. So wala tayong babaguhin sa value, i-rewrite lang natin siya na parang from an improper fraction papuntang mixed fraction. So we do the division, x cubed divided by x squared, we get x, multiply x dun sa divisor, we get this expression, we subtract. At this, we divide the first term of the difference by our divisor, we get, so it's negative 2x squared divided by x squared, get negative 2, multiply, and since the degree of the difference is less than the degree of the divisor, ito na yung remainder. So we can write our rational function, h of x, as x minus 2 plus the fraction, negative 6x plus 4 over x squared minus x minus 2. Now, imagine natin, papalakihin natin yung x na naman. Kasi yun, ang tinitigan natin ay behavior ng rational function pag malaking-malaki na yung x values natin. So will it x approach positive infinity this time? Papunta dun sa positive infinity. Pag yung x natin papunta sa positive infinity, yung x squared minus x minus 2, dahil x squared to, so positive, eh di sobra siyang lalaki. Magiging positive, pupunta yung value niya to positive infinity. Eh ano ba to? This is a fraction na ang denominator ay pumupuntang positive infinity habang lumalaki yung x natin. So the whole fraction will now approach 0. So ano na lang matitira? Matitira na lang sa atin itong linear part. So as x approaches positive infinity, yung buong rational fraction natin, papalapit na lang siya ng papalapit sa x minus 2. So that's the reason why lumalapit yung rational function natin sa y equals x minus 2 kasi pag malaking-malaki na yung x, nawawalan na ng relevance itong fractional term na to dahil yung denominator niya sobrang lumalaki at kinakancel out yung value ng numerator. I hope that makes sense. So to summarize the rule, if the degree of the numerator is greater by 1 compared sa degree ng denominator, yung oblique asymptote natin will be given by y equals yung linear part ng quotient. Tapos yung remainder, ita-drop na natin. Now, what is important here no, is that the horizontal and the oblique asymptotes, they sort of describe yung end behavior ng rational function natin. End behavior meaning pag yung x ay ang laki na ng magnitude, both positive and negative infinity. At bakit ang kinonsider lang natin ay mas malaki lang ng 1 yung degree ng numerator sa denominator. Now, this is not supposed to be discussed anymore. Nakalagay sa curriculum natin. Do not discuss this kasi advanced na. But I hope by just showing you this na mabilis, hindi to part ng kailangan yung isolve. Medyo magka-idea tayo kung bakit yun yung nagiging end behavior. Look at this. This is a rational function na ang numerator mas malaki by 2 yung degree sa denominator. If we do long division, we'll get this expression. At pag pinalapit natin yung x sa infinity, both positive and negative, yung fraction na to na may denominator na may x sa baba, magiging insignificant, mag-a-approach na ng 0. At ang matitirang end behavior sa atin ay itong, kumbaga, whole part ng fraction, which is quadratic. So here, yung red na part, yung reddish-orange na part, siya yung graph ng rational function. But pag lumalaki na yung x values natin, parang lumalapit na lang siya dito sa dashed line, which is the graph of this quadratic. Here, I have a rational function na degree 4 yung numerator, degree 1 yung denominator. And it can be written as this cubic function. So again, yung reddish-orange na graph, that is the graph of the rational function. Pero pag medyo lumalaki na yung x values natin, the graphs will now approach itong dashed blue line na cubic, y equals x cubed minus 13x minus 12, which is like the whole term. Yung parang, which is like yung whole number term no, ng isang mixed fraction. Okay, so I hope that made sense. That is the last lesson for the first quarter. In the lesson notes in K-Hub, I'll be giving more examples para i-work out. Kasi kung i-record ko sa video, medyo, di ba, paulit-ulit na lang siya. But I'll give several examples sa lesson notes. To recap, yung value ng rational function, nag-a-approach siya ng infinity, either positive or negative. Kasi habang lumalapit yung x value natin dun sa magpapa-0 sa denominator kung saan siya undefined, papalapit sa 0 yung buong denominator. Kaya papalaki ng papalaki yung function value. Yung vertical asymptote, it acts as a visual representation no, of the barrier that the graph cannot cross. Kasi undefined siya dun eh. At nag-zoom siya to infinity either positive or negative habang lumalapit siya doon. Now, the horizontal and oblique asymptotes, they approximate the end behavior, yung pag malaking-malaki na yung x, both positive and negative, of rational functions. So thank you very much. It's been a challenging first quarter, and good luck sa ating summative examination, and I'll see you again when the second quarter starts.